Okay, so in this video I'm going to go over how to calculate the gradient of perpendicular lines and how you can use that to find the equation of a perpendicular line. So the first task that you're going to have on Heggerty is how to calculate the gradient of perpendicular lines. So what I mean by a perpendicular line is if we have a set of axes that look like that, and you've got a line that goes through them like so. A perpendicular line is one that goes at a right angle to your existing line. So that's what perpendicular means, at a right angle to. Okay, so let's say we have the line y equals 2x. Okay, that has gradient of 2. Okay, so something that would be perpendicular to that is y is equal to negative a half x. Okay, so if you have a look at this one, notice how the one that is perpendicular is now going in the other direction. Okay, so you're looking for the negative reciprocal. Okay, so the gradient of this one is negative 1/2. So what you do is you basically imagine it as a fraction over 1 and you flip it. So if we had something that had different gradients, and I'll show you how you do it. If we had something that was a third, what would be perpendicular to that would be 3, or negative 3, sorry. Okay. If we had something that was negative 1/4, what would be perpendicular to that would be 4. If you had something that was negative 5/6, what would be perpendicular to that would be positive 6/5. If you had something that was negative 7/3, perpendicular to that would be positive 3/7. Okay, so your rule is the reciprocal and change the sign. So in these cases you flip it and add or take away the negative. Okay, that is always the case for something that is perpendicular. So what I've included is this example down here. So we've got this equation which is y equals 1 minus 2x. Okay. Now, if I wanted to write it in the form y equals mx plus c, the exact same equation would be y is equal to negative 2x plus 1. It's exactly the same. So our gradient here, m is equal to negative 2, but we want a line that's perpendicular. So the perpendicular gradient is going to equal a positive reciprocal of this. So if it's negative 2, m is going to equal positive 1/2. Okay, so that's the line that we've had to begin with. So our perpendicular gradient is 1/2. Now what you were doing yesterday was working with parallel gradient, where the gradient was the same, and using that with y equals mx plus c. Here we're working on the perpendicular gradient, and now I'm going to use that with y equals mx plus c. So that's my m. I'm now going to use this from x and y. So what I do is we use y equals mx plus c for our answer. Now my m is 1/2, but I use the x and y values from the coordinate. So my y value is going to be 2. My m is 1/2. my x is -1, and my c I'm just trying to work out. So I then calculate this and work it through. So what I do is this will be 2 is equal to half of -1, which is -half or -0.5, plus c. I then add the half on, so I add a half, and I would get 2.5 is equal to c. So that's the bit I'm trying to work out. So my entire equation to get any point on that line is y is equal to half. So we're looking for the gradient, the equation of that perpendicular one, equal to half x plus 2.5 or 2.5. You could also write it as y equals 0.5x plus 2.5. Both are absolutely correct. Okay. So this part up here is how to calculate perpendicular lines. Here is how you would calculate the equation of a line that would be perpendicular. Okay? So slowly watch the video and hopefully it'll begin to make a bit of sense. If you need to, do it alongside the Hegarty task as well. Okay, good luck.